Alright guys, hopefully you had a restful 3-day weekend. Again, we're going to jump back at it here. So you guys know the drill. Take a second, pause the video here, try out the warm-up. When you're ready to go, hit that play button. Alright guys, so for essential number 1, solving a multi-step equation. This is the first big unit that we were talking about. How do you solve the following equation? This is a 2-step equation. First thing you should have done is we should have gone minus 5 to both sides. 5's would have canceled out. You would have been left with 3x is equal to 11 minus 5, which is 6. Last thing here you should have done is divide both sides by 3, and you get x is equal to 2. Now again, we've been doing that. We've been solving like more complex problems, of course, but all of them have always been giving you guys just one solution. X equals 2 or x equals 3, 5, whatever it was, right? It was only one solution. Okay, today we're going to talk about when it's not an equal sign, when it's one of these guys right here. Maybe you've seen them before. These are guys what we call inequalities. So when you have an inequality, you actually have more than one solution. We represent that graphically. So that's what we're going to talk about today. So graphing inequalities. How do you graph an inequality with one variable? How do you show all the possible solutions? Because there's actually going to be more than one. All right. So our objective for today, you're going to get this type of problem, something like 2x minus 5. Now notice it no longer has this equal sign. It has what we call an inequality symbol here. This is now greater than or equal to 7. Notice from this example, it works the same way. Plus 5, divide both sides by 2, right? But we have an answer that says x is greater than or equal to 6. It's no longer equal to. You actually have more than one answer here, and we want to represent that on a number line. We want to represent that graphically. So before we jump into that, let's take a second to kind of recall what are the different types of inequalities. So again, I want you guys to copy these down. You need to memorize these and how do these actually work. These are what we call inequalities, these top 1, 2, 3, 4. This is now, the first one is less than. So again, if you see the little smaller side coming up first, we read from left to right. This is the smaller, so I'm going to put small. This is the bigger side. So again, if we start from left to right, this is smaller than, so we say is less than. So again, the small number would go over here, something like 3. The big number over here, something like 8. That would be a true statement. 3 is less than 8. Okay, what about the next one? Is less than or equal to. So whenever we add that little piece at the bottom, it's saying, well, here, let me give you an example. Let me use the number 8 again. That's the big number. So it's saying less than or equal to 8. So I have more than one answer here. I could say something like 6. 6 is less than 8. Absolutely. Okay, what's another one I could have done? 7. 7 is also less than 8. Or I can actually say 8. 8 is actually equal to 8. That would make it a true statement. All right, so again, the next one is strictly greater than. We cannot equal it. But now notice the big side is coming first, the big opening. So we say this is greater than. And now again, if it has the equal to piece at the bottom, it's greater than or equal to in this case. And the last one is, well, you have an equal sign and you have a little dash going through it. We say it is not equal to. So again, take a second, guys, copy these guys down. Make sure you commit these to memory. All right. So let's talk about, you don't have to copy this piece down. I just want you guys to follow along. How do we represent things on a number line? So it says graph the following. X is equal to 5. So here's my number line. I'm going to scoot over all the way to 5. Now, how do I present that I'm equal to, that X is equal to? It's basically we put a little solid dot here right above it that lets us know, hey, that's where we're standing. X is equal to what number? Well, I can see here that's noted with a little dot, a closed dot here, that it's at 5. Okay. Well, let's change it up a bit. What if I say X is not equal to 5? Well, I go to 5, right? That's the number I'm interested, but I'm not going to fill in that circle, that little dot. I'm actually going to keep it open. What that means is that here at 5, if I try walking towards 5, I'm actually going to fall through this hole. I cannot equal it. I can get very, very close to it maybe, but at 5, there's this gap. So we represent that with an open circle. All right. So let's talk about the actual inequalities now. How does this work? This is saying X is less than or equal to 5. Well, let's go to 5. And now because it's equal to, it has the piece at the bottom, I can actually stand at 5. So that's going to be part of my solution, but there's more solutions actually in here. Well, what's a number that is less than 5? 4 is less than 5. 3 is less than 5. 2 is less than 5. 1 is less than 5. 0 is less than 5. Negative 1. There's a ton of possibilities that are less than 5. So how do we represent that on a number line? Well, notice all these numbers are 4, 3, 2, 1. They're over here on the left side, so I'm going to draw an arrow pointing in this direction. That's representing that all my solutions, I can be at 5 and actually equal it, but it's everything less than it, it's also 4, it's also 3, it's also 2, it's also 1, 0, all the way to negative infinity. All right. Well, what if it just says x is less than 5? So again, I go to 5. Now I can't equal it. Remember, it doesn't have the equal to piece at the bottom, so I have to keep it open. But still, what are numbers that are less than 5? So I always like to pick number next to it, something like 4. Well, what way should my arrow be pointing? Well, 4 is towards the left. It's the smaller side. So we drag that arrow in the left direction. That's all the values that are less than 5. Okay. Well, what if I say now x is greater than 5? So similar idea. I go to 5 because I can't equal it. I'm saying it's strictly greater than. So again, I have to keep it open. Okay, 5 does not exist. I can fall through that little hole there. But now it's saying x is greater. So what's a number that's greater, the bigger than 5? That's going to be something like 6, 7, 8, 9, and so forth. Well, where are all these numbers located? Well, 6, 7, they're to the right. So we represent the arrow going out in the right direction. So again, that's saying x is greater than 5. This represents all your possible solutions. All right, let's try it. Well, now what if it equals? How does that change it? Again, go to 5. I can actually equal it. So it's a solid circle. That's one possible answer, but I know that, again, numbers that are greater than 5, in this case, something like 6, 7, 8. So again, my arrow should point towards the right. All right, last one here. X is less than negative 2. Let me change the number up. So you would draw your number line. You'd go over to negative 2. Now again, can I equal negative 2? Nope, I can get very close to it, but I can't equal it. Okay, that's why we leave a hole in the middle there. But numbers that are less than negative 2. So what numbers are less than negative 2? Something like negative 3, negative 4, negative 5, negative 6. Well, where are all these numbers located? To the left. So our arrow goes towards the left here. All right. And then we get to kind of real world examples. Your height h here, okay, must be at least 42 inches in order to ride a roller coaster. So you need to be at least 42 inches. So on a number line, I'm just going to start off with something like 40, 41, 42. And I'm just giving you guys examples here. Just kind of talk about how are we going to graph our solutions. And I'm going to stop right there. But again, at least 42 inches. That means I can be 42. I can actually equal it. So I'm going to fill that in. Well, at least I have to be bigger than 42 inches. Well, where are all the numbers bigger than 42? They're going to be towards the right-hand side. So again, I want to stretch this out as far as I can. Whoa, what happened there? All the solutions are to the right, 42 inches or greater for me to ride this roller coaster. All right, so let's take a look at what is your class activity going to look like? What is it looking like in Algebra 1 when I solve an inequality? So again, take a second, copy this down. X minus 4 is greater than 10. I want to solve it just like I've been doing, right? Solve for x, I have to do inverse of minus 4, which is plus 4 to both sides. Okay, negative 4 and positive 4 will cancel out. You have x is greater than 10 plus 4 was just 14. And there we have it. That is representing my solutions, x greater than 14. But I want a visual representation. I want to see on a number line, what are all the numbers x that are greater than 14? How do I represent that on a number line? Well, let's go ahead. Now I don't want to start at 0. I'm going to start something at maybe like 12, 13, 14, 15, 16. I'll stop here at 17. That's a good enough number line there. So what number am I interested? Well, x is greater than 14. Now again, I'm here at 14. I'm not equal to. I can get very, very close, but I cannot equal. So it's an open circle. Okay, now what are numbers that are greater than 14? Well, let's think about it. What numbers are greater than 14? Something like 15, something like 16, something like 17. Those are all greater than 14. And what direction are these numbers at? 15, 16, 17. They're to the right. And there we have it. So it's an open circle at 14, and the arrow points towards the right. This is what I'll be looking for today, guys. Can you graph your solutions on a number line? All right, that's representing all the solutions. 14. Sorry, not 14, right? 15, 16, 17, and so forth. All right, let's go ahead and do the second one here. Copy it down. We have 3x plus 2 is less than or equal to 8. Well, let me go ahead and solve it. Minus 2, minus 2. I get 3x is less than or equal to, careful not to change that to an equal sign. 8 minus 2 is 6. If I divide both sides by 3 here, I get x is less than or equal to 2. Now again, yep, that's great. I have my solutions there, but I want to represent it visually. All right, let me go ahead and draw a quick little number line here. I'm going to start here at maybe, let me get a few little dots going here. I'll start at 0. Why not? 0, 1, 2, 3, 4, 5. Well, what number are we interested in? Let's go over to 2. Now it's saying x is less than or equal to 2, so I can actually stand on 2. 2 is actually part of my solution, so it's going to be a closed circle. Now, what are numbers that are less than 2? Well, example would be number 1. 1 is less than 2. Something like 0. 0 is less than 2. Negative 1 is less than 2. Where are all these numbers located? They're located to the left, so we draw an arrow going towards the left. All right, guys, take a second. I want you guys to pick one. Try it out. When you're ready to go, hit that play button. All right, so let's run through this. The first one, you should have done +1 on both sides. The negative one and the positive one cancel out. You have 3x is still greater than, what's -4 + 1? That's going to be -3. Careful here with your signs, right? Different signs, subtract, take the sign of the larger one. Last thing you should have done here is divide by 3, divide by 3. X is greater than, what's a -3 divided by a +3? That is going to be -1. All right, so there we have it. My solution is all the x's that are greater than -1. Now let me go ahead and represent that on the number line. There's 0, there's 1, there's 2, there's 3. To the left it's -1, -2. That's good enough right there. So let's go ahead and let's talk about this. X is greater than -1. Well, let's go ahead and go to -1. Can I equal -1? Nope. I can get close to it, but that's not part of your solution, so it has to stay open. You're going to fall through that -1 if you try to stand there. Now, x is greater than, well, what numbers are greater than a -1? Well, all those numbers to the right, something like a 1, something like a 2, a 3, a 4, all these numbers are bigger than the -1, so I want my arrow pointing in that direction towards the right in this case. All right, for the beyond standard, you should have distributed first. 6x, so 2 times 3 is 6x. 2 times 6 is 12. It's greater than or equal to 18. It's just a two-step equation at this point. -12 minus 12. We get 6x is greater than or equal to 6. Last thing I do is divide both sides by 6, and I get, 6x is greater than or equal to 1. All right, let me change the colors here. So again, that's my answer right there, but I want to represent it on a number line. So let's go ahead and put 0, 1, 2, 3, 4, 5. All right, let's go ahead to number 1. Now I can actually equal, so I'm going to put a closed dot. I can actually, 1 is part of my solution. Now what numbers are greater than 1? Well, something like 2, 3, 4. So we're going to put our arrow going towards the right. All right, guys, so there you have it. That is the lesson for today. So again, we're still solving, think of it a multi-step, not an equation anymore, it's an inequality symbol, right? So I am forced to represent all my solutions on a number line. So again, let me finish this off here. X is greater than or equal to 6. Last example here, I would draw a number line. Here's 3, here's 4, here's 5, here's 6, here's 7. So I'm interested in the number 6. I can equal 6. 6 is part of my solution. Now again, greater than, what are numbers that are greater than 6? Something like 7, 8, 9. Those are all going to be towards the right. So again, what I'll be looking for, guys, today is this piece here and the actual graph on the number line itself. All right, here you guys go. This is your class activity. You guys know the drill. So finish these 6 problems. Go check your answers with the sub. If everything's perfect, turn it into the inbox. If you have to make a few corrections, guys, fix it real quick. Double check again, then turn it into the inbox. Now notice on number 1, it's already solved. Okay, you just have to graph it. Number 2, 3, 4, 5, and 6, you do have to kind of do a 1-step or a 2-step equation and then go ahead and graph it. All right, guys, have a great day. I will see you guys tomorrow.